the rule that each atom of carbon, oxygen, and nitrogen reacts to achieve a complete outer shell of 8 valence electrons, add unshared pairs of electrons as necessary to complete the valence shell of each atom in these ions. Then assign formal charges as appropriate. So what this question is telling us is that for carbon, oxygen, and nitrogen, we want to have 8 electrons, and if we do not have 8 electrons, we have to put lone electrons. Let's see here, I have a carbon. It has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Each bond is 2 electrons. It has 4 bonds, so it has 8 electrons. It has a complete octet, so this is fine. This carbon, like its partner, has 1, 2, 3, 4 bonds, 2 electrons each. There are 8 electrons here, so this is fine as well. Now let's go to the oxygen. It has 1, 2. So it has only 2 electrons, but it needs to have 8. That means we have to fill in the remaining electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now my oxygen is happy. Let's continue here. This carbon has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. This carbon, 1, 2, 3, 4, 5, 6. 6 only, but it wants to have 8, so we need to give it 2 more electrons. Now let's go to the nitrogen, 4 bonds, so it has 8. This carbon has 1, 2, 3, 4 bonds as well, so it has 8 as well. This carbon has 1, 2, 3, 4, 5, 6, 7, 8. It has 4 bonds also. It's happy. This oxygen has 1, 2, 3, 4. It needs more. 5, 6, 7, 8. Now it's happy. What about this oxygen? 1, 2, 3, 4, 5, 6, 7, 8. So we just went ahead and filled in the electrons. Now it says that we have to assign formal charges as appropriate. So first let's define how to figure out the formal charge. So let's write it out. Formal charge is equal to the number of valence electrons minus number of bonds plus number of lone electrons. Let's go ahead and use this formula to calculate the formal charges. We don't need to do that for hydrogen because hydrogen it only needs 2 electrons, so it is happy and it will not have a formal charge. Now let's go ahead and look at this oxygen. This oxygen has, how many valence electrons does an oxygen have? The number of valence electrons will be equal to the group number on the periodic table. If you take a look at the oxygen on the periodic table, it will be in group 6. So it has 6 valence electrons. Some periodic tables say 16, but we will drop the 10. So it's going to be 6 minus. Now let's count how many of bonds does it have. It has 1 bond here, plus number of lone electrons, 1, 2, 3, 4, 5, 6. 6 minus 7 is equal minus 1. So we put minus 1 here. If you try these carbons, they will be fine. They will not have a formal charge. Their formal charge will be 0 because a carbon has 4 valence electrons and it has 4 bonds. 4 minus 4 will be 0. So I'm just going to skip it. And I'm going to move to B. And this carbon, how many valence electrons does the carbon have? It's in group 4 on the periodic table. So it has 4 valence electrons minus number of bonds. This carbon has 1, 2, 3 bonds minus 3 plus number of lone electrons, 1, 2. 2. 4 minus 5 is minus 1. So this carbon has to have a minus 1 charge. Let's go ahead and look at C. Let's look at this nitrogen. Nitrogen is group 5 of the periodic table. It has 5 valence electrons minus, how many bonds does it have? 1, 2, 3, 4. It has 4 bonds plus, how many lone electrons does it have? None. We did not give it any lone electrons and it didn't have any to begin with. So this is 0. 5 minus 4 is plus 1. So this nitrogen must have a plus 1 charge. Now let's take a look at this oxygen. The oxygen has 6 valence electrons because it's in group 6, and it has one bond, 1 plus, it has 1, 2, 3, 4, 5, 6 electrons. 6 minus 7 is equal minus 1. So this must have minus 1 charge. What about this oxygen? Again, it's an oxygen, it's in group 6, so it has 6 valence electrons minus, how many bonds does it have? 1, 2. 2 bonds plus, how many electrons does it have? 1, 2, 3, 4. 6 minus 6 is 0. We do not show 0, so this has no formal charge. This is Maya Alochi from Transformation Tutoring, and I really hope that you found this video helpful.